Hi everybody. So in this video, we're going to look at the rectangular hyperbola for our conic section. And the shape of this is given in example 1, where it looks a little bit like a reciprocal graph. In the first example, we're going to derive the Cartesian equation from its parametric form, and then in examples 2, 3, and 4, we'll look at more coordinate geometry type problems. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. Okay, so for example 1, we're given that the general point P on the curve has the coordinate ct and c over t, and we've been asked to use this to show that the Cartesian equation of a curve is xy equals c squared. So you can see that we have our x value here, and this is our y value. So to find the Cartesian equation, we can rearrange the x to make t the subject, and then substitute this value of t in terms of x into our equation for y. So if we begin by dividing both sides by c, then we'll get x over c is equal to t. And then we'll substitute this value of t into here. So y will equal c over x divided by c. And we can simplify this fraction. If we multiply the numerator and denominator by c, then these will cancel. And we'll get y is equal to c squared over x. Now we can move this division of x to the left-hand side. So we get xy is equal to c squared. And this is the Cartesian form for a rectangular hyperbola. So for example 2, we're given that the hyperbola has these parametric equations, and we've been asked to work out the Cartesian equation. So I'm going to show you two ways of doing this. If we begin with the parametric, we know x equals 5t. We'll divide both sides by 5. So t will equal x over 5. Then we'll substitute this into y. So y will equal 5 divided by x over 5. Again, we'll cancel out this division. We'll multiply the numerator and denominator by the 5. And these will cancel. So we get y will be 25 over x. And then we'll move this division to the left-hand side. So we get xy equals 25. Now I think it's much simpler if we use the Cartesian equation first. We know xy equals c squared. And we can see from the general form here that c is 5. So if c equals 5, then xy must equal 25. Okay. So that's how you convert from parametric to Cartesian. In the next few examples, we're going to look at more problem-solving type questions. Okay, so for example 3, we're given the rectangular hyperbola h as these parametric equations, and we're told that p and q are points on h such that t is 0.5 at p and t is negative 2, and this is at q. We've been asked to work out the exact length of a line segment PQ, and that'll be this line segment here. Okay? So if we find the coordinates at P and the coordinates at Q, we can use Pythagoras' theorem to find the length of that line segment. So we'll work out when t equals 0.5. We'll substitute this into our parametric equations here. So x will be a half of 8, which gives us 4, and y will be 8 divided by a half, which gives us 16. So I'll label this on the graph. We've got 4 for x, 16 for y. And then when t equals negative 2, the x value will have 8 times negative 2, give us negative 16, and 8 divided by negative 2 will give us negative 4. So I'll show these on the graph as well. So we've got negative 16 for x and negative 4 for y. And just to make this clearer, I'm going to sketch this out separately. So now we've got the line segment, we can find its length using Pythagoras' theorem. So we'll make it into a right angle triangle. Then we know its base will go from negative 16 to 4. So we'll have a base of 20. And the height will go from negative 4 to 16, so again 20. So PQ will be the square root of 20 squared plus another 20 squared. And this will give us the square root of 800. And we can simplify this as 20 root 2 units. Okay? Let's try one more example. So in example 4, we're given these points A and B, and we're told that they both lie on the hyperbola with the general Cartesian equation. We've been asked to show that chord AB has this equation. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing I'm going to do is I'm going to sketch this graph. So we've got the rectangular hyperbola. If I make a point here, we'll call this point A. We know the x value will be the CA, and the y value C over A. We'll do the same for point B. We'll say this is over here. This will have an x value of CB and a y value of C over B. What we want is the equation of this chord A to B. So we know the chord is a straight line. So we can use the standard equation for a straight line graph to work out this chord. We know x1 and y1 we can take from these coordinates. So we just need to work out the gradient m. And we know this will be negative because it's going downwards. So a gradient will be negative with change in y divided by the change in x. The change in y will be C over A minus C over B. And the change in x will be CB minus CA. So now we can tidy up this fraction. We can factor out the C in the numerator and denominator. And we can see that these will cancel. And then we can multiply this fraction by B and this one by A to give us a common denominator. And now we can divide the numerator and denominator by B minus A, so these will cancel. And we get the gradient as negative 1 over AB. We can substitute this into the equation for a straight line. We'll multiply this by x minus our coordinate for x, which is CA. And this will equal y minus C over A. So at this point, we'll move AB to the right-hand side, and we'll multiply out this negative. So we get negative x plus VCA will equal AB lots of y minus C over A. We'll expand out this bracket, so we get ABY, so we'll get minus CB. Then all we need to do is move this negative x to the right-hand side, and this negative CB to the left-hand side. So we get CA plus CB will equal ABY plus VX. I'm going to move this over to here and that over to here, so it looks a bit more like this. And then all we have to do now is factor out this C. And here we've got the equation of a chord. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.